Hi, folks. My name's Rafael Colson. I'm from Hortonworks, and welcome to another Future Data Meetup. Tonight's meetup is going to be around data science powered by HAWQ and MADlib. We have our guest here, Tushar from Pivotal, and he'll be doing the presentation. So with that, Tushar.
Awesome. Thanks, Rafael. Thank you. So, good evening. Curious, how many of you have heard of Pivotal? I was having a chat with a few people. There was a confusion around what Pivotal is and how Pivotal is related to Hortonworks, so I'm just going to get started with that. Have you heard of Pivotal? Yeah? Okay. Perfect. Awesome. Yeah, great. So how long have you known him? 25, 30 years? No? 12 years? Yeah, awesome. So Rob Mee is the CEO of Pivotal. So Pivotal was formed in 2013 it's a startup, but it was started with about 1,000 people, and now we have about 2,000 people who work for Pivotal across the world. The name Pivotal came from the company which Rob Mee had started about 26, 27 years ago in San Francisco. The company was started to help enterprises and startups build software the right way. Rob Mee and the entire team who started that company, Pivotal Labs, they decided to, they went through different iterations and found the best approach to building software. And when in about 2011, 2012, Greenplum, which was a startup which was just acquired by EMC, acquired Pivotal Labs and brought them into the family, as we call it, as we used to call it in the EMC world. When we did that, Rob Mee was one of the leaders who came from Pivotal Labs. At the same time, VMware, which was also owned, majorly owned by EMC, was led by the ex-CEO there who stepped down to start Pivotal. He did the same thing with VMware, and he decided to do it again with Pivotal. The whole vision was to enable the industry to build software in a better way. And the relationship between Pivotal Labs and the other assets within VMware and EMC came together to form this company. So the assets were basically two major portfolios in software development. One was the software development approach from Pivotal Labs and the platform where you deploy software in cloud, right? And that's the Pivotal Cloud Foundry plot. I will explain a little bit later about what that is. It's basically, at a high level, it's an operating system for multiple clouds. When you build an application, you don't have to worry about where it's going to get deployed. It works seamlessly the same way in different clouds in Google Compute Engine or Azure or Amazon, right? That's the idea there. And then the last portion came from VMware, which came from VMware and EMC, was the data portfolio. And in the data portfolio, we have Greenplum, Gemfire, and HAWQ, right? Those are the major components there. Greenplum is basically an MPP database system, started about 12 years ago, 13 years ago here in Silicon Valley. Competes with companies like Vertica and Teradata and has been doing that for a long time now. HAWQ came from Greenplum. About 5 years ago, we pulled Greenplum logic and put it in Hadoop because there was nothing like that in the Hadoop world back then. And then the last portion is Gemfire, which is in-memory data grid. That's basically was started about 14 years ago on the Wall Street for high-speed transactions. And if you look at Wall Street still uses it, but it's also now used at many places like India Railway and China Railway. The world's largest railway reservation systems use that to manage the ever-increasing traffic of transactions. So when I say that, I mean like millions of transactions a second is what Gemfire is designed for. Now, today, we are not going to talk about all those as much as we are going to talk about these products. Apache HAWQ and Apache MADlib. This is where we are tightly integrated with Hortonworks, and that is why we are here today, right? So Apache HAWQ is an MPP SQL interface into your Hadoop platform. And then Apache MADlib is a data science algorithms, a set of data science algorithms, which we will talk about today, right? Any questions so far? We had a few questions from about Pivotal and what's the relationship. Good? Awesome. So let's get started. Many of you may have actually started venturing down the path of Hadoop. And many customers we talk to who have been using Hadoop for 4 or 5 years, they are all struggling a little. And pretty much everybody has this problem. Like anytime we ask them, hey, can you run complex SQLs on a large data set in Hadoop interactively? Right? Most of the time we get an answer, not really. Like we have to submit a job and wait a few minutes, few hours to get back, right? The other question we usually hear is, hey, can you take your existing SQL code and run it, like your ANSI SQL, or take your BI tools and run it on Hadoop? It sort of works, right? It doesn't really work full-fledged, right? Can you analyze different data sets? Like if you have a bunch of data in HBase, do you have a bunch of data in Spark, a bunch of data in Hive? Can you analyze all that data set together in a single SQL statement? That's usually an answer is no, not really, right? And then the last piece is machine learning, right? Machine learning, data science on large data sets. Doing that in Hadoop world is not really that easy. And if you end up doing it, you end up writing a long code in some language which takes a long time to build it and takes a long time to tweak it and update it and that sort of thing. SQL just makes it easier, and we'll see a few examples of that later. So with that in mind, right? So this is surveys which came out from Gartner and Wikibon. When people were asked, the customers who have been using Hadoop for a long time were asked, hey, what's your experience with Hadoop? How comfortable are you saying your Hadoop projects have been greatly successful, right? If you ask around, the business guys or business side of people usually say maybe like third of my projects are okay. My 70% of investment, I'm not happy with that, right? If you ask the IT administrative side, or maybe even a deep data scientist who's hardcore PySpark programmer, for example, right? Those people usually say at least half my projects are successful, sometimes more than half. But in general, more than half the people are not really happy or fully successful with what they ventured out on, right? And we started looking at it, so did all these analysts. We started looking at it around 2010, 2011. This is from last year, so it exists even today, right? The main reason which was like obvious was SQL, missing full-blown ANSI SQL which performs at interactive speeds. That was missing from Hadoop world until now, right? So the same problem, looking at it a different way, right? You have your existing business analysts. They are used to using their SQL applications, existing SAS users, Tableau users, or any other. Tableau is actually one of the good ones who has connectivity into HDFS directly. But many other tools that don't really work without an ANSI SQL interface, right? It gets worse when you go to data scientists, right? So data scientists are the ones who like good SQL for machine learning. They struggle because of lack of that. Even if you write your code in some other language, performance is still a problem. And we'll talk more in depth about how that gets solved in HAWQ. So when a data scientist hits that problem where the performance is a poor performance problem, they end up doing sampling. That's a first thing a data scientist would do, right? Okay, my job against my 50 billion row table is going to take 20 minutes. I don't have 20 minutes to wait to see if that was right or not, right? I'm going to run it on maybe like 2,000 rows and see if it works, right? That's what happens. So when you start sampling, you end up doing that job repetitively, right? As a data scientist, you're pulling some samples, running a job on a smaller set, try it on a larger set, maybe it will work, right? You end up building features in your data science model which are not as cool or as efficient as it could be, right? And then the third piece is you open up your data platform. Let's assume you open up your data platform, Hadoop-based data platform or data lake to a data scientist who understands maybe one of the languages or maybe just SQL, right? And you give them, hey, here's the data warehouse in Hive. Here is my HBase data, which is my transactional data. Now go analyze all that stuff. And it becomes harder because now they have to figure out multiple different data formats, multiple different data types, all that stuff. A data scientist who is basically a statistician and your domain expert now is spending time doing infrastructure-related things, systems-related things, which they should not be wasting their time on. The system should be built in a way that your data scientists are more efficient. They can go through their job quickly, not spend time moving data around, not spend time figuring out which data type goes where, right? That's not what they should be spending time with. So that's where Apache HAWQ comes into picture. So Apache HAWQ is basically a highly efficient MPP system. We got that MPP platform from our roots in Greenplum. So 10 plus years of development happened in building a massively parallel infrastructure which knows how to solve SQL queries in parallel fashion. Right? It also brings low latency queries, so you're not waiting there for seconds or minutes or hours. Right? You can expect queries which are going to come back in milliseconds, for example. Right? It scales out, right? It scales out nicely with your Hadoop infrastructure. So petabyte scalability is not a problem with this infrastructure, right? It has asset reliability. So if you're actually running a business critical application on HAWQ, right, it gives you asset reliability. So when you're loading data and somebody else is looking at that data set won't be available until everything is committed on your entire data set. It's not like file-based access there, right? It's built into SQL there. So as a user, you don't have to worry about, hey, is this data current with the other data set which I'm trying to correlate with? You don't have that problem anymore. You have full-blown SQL, ANSI SQL compatibility. The 92 standards, the 99, the 2003, including all OLAP functionality, windowing functions, all the usual things which you're used to doing in a real database, right? And then the last piece, which HAWQ brings here, is the advanced cost-based optimizer. I will talk a little bit in depth about that a little later. It's something which we are truly proud about, and it's built ground up for big data, and also keeping in mind different types of file storage systems, including Hadoop and cloud storage systems. Any questions so far? No. Cool. That's at a high level. Let's take a look at few components which go into making HAWQ what it is, right? Pivotal HDB, that's our enterprise name. HAWQ is an Apache name. I keep interchanging those names, so excuse me there. What does this bring, right? So if you look at it first of all, it works. It's well integrated with your existing Hortonworks data platform you may have, right? It works seamlessly with that. It's nicely integrated and managed through Ambari, right? You just go on Ambari and say, I want to add a service, HAWQ service, and I want to run it on these 10 nodes on my 25 node cluster, right? And then it goes and figures out where to set it up, and it's automatically done for you, right? From connectivity perspective, right, it brings ANSI SQL standards, so you don't have to worry about, hey, do I have to write like SQL-like thing, or I don't have to, sorry, yeah, please. Turn down that thing? Some help, please. It's doing it right now. Better? Awesome. Perfect. Sorry about that. So from connectivity perspective, you don't have to worry about, do I have to write like a SQL-like thing, right? It's full-blown ANSI SQL available for you on Hadoop now. It comes with all the OLAP extensions, so don't have to worry about, hey, I have a windowing function. What do I do with that? So if I have to rewrite that into a self-join with my table, no, you don't have to worry about it. You can take that windowing function and run it on top of your existing infrastructure. Yes?
So is the big differentiator between HAWQ and, I don't know, Hive, Spark SQL, and all the other solutions, the fact that it's SQL 2003 compatible, ANSI SQL compatible?
Mm-hmm.
Is that okay? So some BI tool that interfaces with it would never know that Hadoop's behind it?
Sure. So we are recording and it's live streaming, so I'm going to repeat the question. The question was the big difference between HAWQ versus any other tool like Hive or something else. Is it 2003 compatibility and how it matters? So short answer is yes, right? You don't have to worry about rewriting your queries. You don't have to worry about connecting any tool, ETL, BI, anything which you may be using. It works seamlessly as if it's any other real database. And then the JDBC, ODBC connectivity, that comes by default with any database, right? Let's take a look at the other side of the board there. It helps you discover new relationships between your data sets. What we mean by there is you don't have to worry about writing different code for different data formats or data storage systems within your Hadoop ecosystem. Hadoop ecosystem is an amazing ecosystem, right? It has a lot of different tools which you can use. Data gets stored disparately. And if you think about it, over time, it becomes, again, silos, right? The analysts don't have access to all of that data. It's portions and pockets of data now. You don't have to worry about, hey, how do I correlate that? Or how do I build new relationships between these two data sets, right? I will show you an example how, even if you have your data in Hive, how do you query it using the same SQL as if you're running it in HAWQ, right? We'll talk about that. It enables data scientists to do their real job. and we'll see how using MADlib. And then you can query all data types, and as we talked about it, right? It has all different things built into it. It also comes with yarn management, right? Support. So if you have a cluster which is yarn deployed or managed by yarn from resources standpoint, when you add HAWQ, it knows, it talks to yarn nicely, and it runs jobs where the queries are space is available to run the job. And to talk about that portion, let's get a little deeper. Any questions so far here? Yeah.
When you said the ACID plus transaction, right?
Yes.
Let's say the use case like banking scenario, because it's transactional and then distributed, right?
Correct.
So how the locking is happening? See, let's say if it is RDBMS like Oracle or something, it's so one at a time. Like if I'm taking some money from the ATM, like it's locked.
Correct.
How in the distributed environment, how it is it locked?
Right. So transactional, so that ACID plus transactional question, right? That is about, so question was, in case of a banking scenario, if a job is happening, and because this is a distributed architecture, how does it manage locking across the system? For that, we need to go to the next slide, which will explain it better. Short answer is, there's a master node which controls everything, and we'll talk about that real quick, right? Anything else? Awesome. Oh, yeah, please.
So since this is the native Hadoop SQL database, how do you benchmark between this one and the traditional good old Oracle database?
Sure. So the question was, how do we benchmark Hadoop native database versus Oracle? Oracle, it depends on what you're doing with that. The answer is, so these two are sort of tied together. So if you're looking at transactional systems, like, I want just one row at a time, Hadoop is not designed for that, right? So if you look at that, that's not what the use case is typically. This is for data science, data analytics, large data volumes at a time. So you're running jobs on, hey, what has happened in the last 15 years? And based on that, depending on what's happening today, how do I predict what may happen for the future use case? So you're not looking at, hey, what is the speed to insert or update one row? As long as you're not looking at that, if you're looking at a bulk data set, this brings you real world data warehousing experience to your Hadoop infrastructure. So how does that locking work? And this will explain that nicely. So at a high level, this is still not going too much in depth. So as an end user, anybody who comes in over JDBC or ODBC connection or any other tool which connects to the HAWQ infrastructure, it connects to this central piece, right? Centralized piece. That's basically the master, as we call it, HAWQ master. It's not much different than an HBase master or a Hive master node would be, right? That does a few things. It takes that query, the SQL query or any other language query. We will talk about languages later, but let's stick to SQL for now. It takes that query, it parses that query, figures out if the syntax is good and all that stuff, and then it passes that to a planner or an optimizer. And that optimizer takes that query, understands based on the data set it knows it holds, this system holds, and what you're trying to do, it builds the best execution plan for that job. Once it builds that execution plan, it sends it to, so it has two interactions there. First of all, resource manager. This is the second tier resource management. The first tier is yarn, right? It checks with yarn and says, hey, yarn, where are the available slots? Where can I run? I have a 100 node cluster or 1,000 node cluster. Which nodes are less busy? That's the first step, right? Second step is it will check within itself how many jobs can this particular user or this particular group run, and how powerful those jobs or how fast those jobs can be executed. So there are multiple levels of resource queue management, workload management built into the product on top of yarn. So that happens, and then it checks with name node and says, okay, where is this data? Right? I want to run my job as close to my data as possible, right? That's what Hadoop was designed for, right? So it checks with yarn, finds all the slots which it has available, checks with name node, gets all the blocks it needs to process, and then matches those up, and then it ships that to query dispatcher or a coordinator process there. That process will take that job and ship that job or dispatch that job to your Hadoop infrastructure. Right? And then there is this notion called segment. It's basically a logical process, or actually physical process, which understands how to take that dispatched job and execute that. So let's say your job needs 4 different tables. So it knows it needs to start 4 readers on that node. So when that job comes down to the segment process, it will take that and create, it spins up virtual segments as long as Yarn allows it. So if Yarn says, okay, you have 4 processing slots, go have at it, it will start 4 of those readers on that node. The other node may just need 2 blocks, and it will just start 2 readers, for example, right? So that happens, and it accesses data from the local data node, and then it starts processing. The interconnect piece is critical here. So the interconnect is where we don't, it's unlike MapReduce or anything else you may be used to, we don't try to write to disk at all, right? So all the processing happens in memory, and if it needs to join that data set with the data which is not on that node, it sends that portion of the data to the other side, to the other node, and that happens over here. So that interconnect is basically a physical network framework. On top of that, we have a logical code base, basically, which understands how to move this data fast. It's UDP based, under the skin, it's UDP based protocol, but we have built some logic on top of it to move that data, shuffle that data around when needed. So there is no HDFS writes here, right? Once the data gets processed, it gets shipped back to the main node where your SQL tools are connected, BI tools or anything else which may be, and the result goes back to the tools. There is this fault tolerance service, which is also a critical one, right? So the way Zookeeper manages, hey, which is my name node on or not, and then if it will start up your secondary node if the first node goes down. This does the same thing. It knows exactly which nodes are actually processing, which segment processes on HAWQ are actually active, and it will work only with those nodes. If one goes down, it will tell the other guy, the guy who has the other block, the copy of that block, it will say, okay, this first server is not responding. You continue processing that data set. Yes.
I'm sorry. Educate me.
Sure.
Is this HAWQ running on top of your existing Hadoop infrastructure with all the other stuff going on, or is it sort of dedicated to?
So the question was, is HAWQ running on the existing Hadoop infrastructure, or can I add it?
It's another application.
Yeah, the question is, can I add it to my existing Hortonworks cluster, or do I need a separate cluster? The answer is it runs inside the same cluster. So that is the core. That was the core reason why we built HAWQ, right? Before that, we had Greenplum connecting into Hadoop. This is like 7 years ago, right? Yeah. We were connecting Greenplum. Greenplum is very similar, but it's a separate cluster, which was doing data analytics for people. And there was a Hadoop cluster, and we had connectors which reads and writes between those 2 nodes. And that's still needed. A lot of people still need that, but that's a very different use case. About 5-6 years ago, when customers started asking us, hey, we don't want to manage these 2 clusters, right? We just want everything in Hadoop. And that is why we built HAWQ, and HAWQ runs inside your existing Hadoop infrastructure as a service.
So the value proposition is that this Greenplum's way is to creep onto existing Hadoop installations. Rather than people buying a dedicated Greenplum thing, now they can just creep onto their
Sure. So two ways. So the question was, is it Greenplum's way to creep on to existing Hadoop infrastructure? It's a good it's funny, but it's sort of true, right? If you think about it, Greenplum and HAWQ are still quite different. I will explain a little later.
Greenplum made HDB, right?
What's that again?
You say Greenplum made HDB, right?
Yes. So Greenplum is where Greenplum is where this whole logic started, and it came into this world, into the Hadoop world. So now you don't need 2 different infrastructures. The one thing I wanted to make, one point I wanted to make there was, HAWQ actually brings you SQL into your Hadoop world, right? A full-blown SQL, and that's still missing, right? And that is what I look at HAWQ as, instead of looking at the other way around.
You talk about how there's pieces of Greenplum that were open source as Apache HAWQ.
Yeah, I was going to talk about that a little later, but we can touch on that now. So 2015 or 15 is when we open source all of the products from Pivotal, right? Every single product which Pivotal builds is an open source product, including HAWQ, including Greenplum. One of the things which is common between HAWQ and Greenplum is that guy, the optimizer, right? So the optimizer is the logical, it's like a brain behind how to process this data the best way, right? So we pulled that optimizer out, and internally we call it ORCA, O-R-C-A. So we took that, and it's still built as a separate product. It's also open source, and then the execution engines, Greenplum as well as HAWQ, are also open source out in Apache world. Does that? Yeah, perfect. So that is the internal processing of HAWQ inside your Hadoop environment. Now, if you have data in Hive or HBase or anything, you can access that data locally because you are in the same infrastructure. But you can also create your own data types or create your own file access patterns using something which is called PXF. So if you have any external systems, this could be anything. This could be your mainframe. This could be your Oracle. This could be any data source. You can access as if you're running it in your same infrastructure. But the difference will be it's not in the same infrastructure, right? So it's going over the network and getting that data for you from anywhere you have it. And we'll talk a little bit more about PXF real quick. Oh, sorry, slide problem here. So PXF, Pivotal Extensions Framework. What that is basically a way to access external data from HAWQ at a high level, right? It enables you connectivity between HDB and other things like Hive data or HBase data or anything else like Avro or Cassandra or Oracle or anything else you may have. Or if you have your own file formats, you can build a custom extension. PXF is basically a collection of 4 Java classes. You just extend those. Up to 4 classes you need to extend. Minimum is 3 classes. One is a reader. One is which knows how to write the data back. One is which knows how to analyze that data set. Analyze is the database term to collect histogram on your existing data, right? So that's a simple way. We have customers who have started doing that right as soon as we open source this. So a quick, the day we open sourced it, we had about 4 different customers who submitted a pull request with 4 different extensions. So even if you build any custom extension, if you have something which you think you are using and maybe will benefit somebody else, send us a pull request that goes back into the Apache HAWQ, and anybody else can start using that and leverage the work which you have done. So if you feel like you can commit back into the world, right? What it also gives you is there are a lot of customers who have their data warehouses built on Hive, and they want to start using SAS to connect to that data. SAS doesn't really work as nicely directly with that existing Hadoop infrastructures, right? That's one example. The other one would be you have data in Hive, but you want to start using ANSI SQL. You're tired of using just limited SQL there, right? Or you want to start doing machine learning and data science models, building those models in SQL, and you don't have any way to do it. You don't have to worry about moving that data or moving that logic day one, because it's always hard for anybody to pick up something and start doing some new thing, right? So you can use PXF to read and write into other tools in the Hadoop ecosystem. What we also do is we integrate HAWQ nicely with HCatalog. So all the data which you already have in Hive, I will show you a couple examples after this. You literally write same ANSI SQL and say, select from hcatalog.default or whatever schema definition you may have, get those columns for me and run logistical regression in my SQL. And we'll see a little bit about that. Yes?
I'm sorry for asking so many questions.
No, you're fine.
I'm confused by your diagram. What's the big black circle? Is that HAWQ?
That is HAWQ.
Okay, then I'm surprised HAWQ is so separated from the HDFS data lake. Is the idea that HAWQ allows you to run native SQL on the HDFS data lake?
Yeah, so good question. So your question was, in the diagram, it looks like HAWQ is outside the HDFS data lake.
Now I thought it would be yet another arrow down into the data lake.
Got it. Yeah. So good question. So if you look at it, the way Hive and HBase is reading and writing the data, what I have tried to depict here in the diagram is all these files are also on HDFS just the way this is. And HAWQ knows how to access those files, or HBase, or Hive, HCatalog. That's the idea. So it doesn't have to worry about the infrastructure. This is in my diagram. This is the infrastructure.
The lake is the whole thing, right?
Correct.
And what you're talking there is the HDFS file system. Each of those is a formatted file, suspended or right?
Yeah. Yes. So yeah, the data lake is the whole Hadoop ecosystem you may have, right? It's not just the file system.
Oh, you're saying this is the formats which HAWQ can read.
Correct. So this is something which comes out of the box.
Sorry, the arrows have me confused. Data, it suggests data movement.
Yeah. It's not data movement. It's access. what you can access out of the box and what you need custom extensions for. Anything else on this? What's that again? Yeah, so we have customers who have built custom extensions for MongoDB, Cassandra, a few other tools out there. Oracle is a common one. It's as simple as saying, take your connection string, put your SQL in there, and just create an external table and say PXF, go access that. Yeah, if you have a Mongo, if you build something, if you want to submit a pull request, you can do that as well. And I'll make sure our team takes a look at it. Cool. Let's jump to the next one. MADlib. So MADlib is a collection of statistical functions, statistical mathematical functions, which are most commonly used by data scientists, right? It's a easiest way to access your data and do machine learning, do data science model building, feature building in SQL layer. But you don't have to worry about learning new code or writing a lot of code. It's built in for that. So what I mean by that is what we have done over the last 5-7 years is it started with Greenplum. It runs with the same MADlib works with HDB, Greenplum, or any Postgres-based system, right? What we started doing was a lot of customers asked us, hey, I have this R code. It runs, but it's not parallelizable. It's hard to parallelize R code. What can you do for us, right? So we looked at it and we took those commonly used 55, 60 functions. I will take a quick peek at the list of the functions right after this, which are used by every data scientist day in and day out. So we took those and we parallelized those. So all you have to do is you just say select star from this function. Here's my input table. Generate my output or build my data science model there, right? Train my data model there. And it's that simple. So we simplified the implementation of those algorithms in MADlib. It has been open source since day one. In 2015, along with all our products, we moved MADlib into Apache world as well. So it's Apache MADlib now. Yes?
I'm sorry, so what goes into houses.out? Is it the model parameters?
This one?
Yeah.
Yeah, so no. So parameters are go in an array here, right? That's the feature set you're building. This is your input table, this is your output table.
Right, but the table is holding model parameters
yes.
that you can predict in the future.
Correct. So the output of that model, it goes into that table. Yes, you're right. Yeah. And we will take we'll take a look at a few examples of that real quick here. I think this one was for something related to houses and MLS data set.
You know, it looks like it's predicting house price.
Yeah, based on number of bedrooms. Yeah. Great. And here's a list of some of the top used functions, right? You have a bunch of linear models, bunch of matrix factorization, building linear systems, right? And a bunch of other machine learning algorithms there, including time series and path functions. This is a short list of the large options you have in MADlib.
Is this migrating a pivotal product also? Was this a pivotal product originally too?
This has been a pivotal product, and this has been an open source product from Pivotal. I think before that, I don't remember. Yeah, it was part of Greenplum EMC, and it has this portion has always been open source. In 2015, we moved this. 2011, I think, yeah. And we moved in 2015. We moved along with all the products. We moved Apache, we moved MADlib into Apache MADlib. Question.
So how do you compare this with the Spark MADlib versus the H2O?
Sure.
They are all machine learning
Sure.
libraries.
Yeah.
Obviously, the major difference is this work with the standard SQL versus the other two. Is based on the Hadoop.
Sure.
But other than that, what's the difference between
Sure.
these three?
So the question was, what's the difference between MADlib versus MLlib or any other machine learning capabilities out there in Hadoop ecosystem? So first of all, you answered the first question, first point there, right? It brings machine learning to your standard ANSI SQL. That's the first one. Second one is extreme, like if you look at it, the available things which you can do in MADlib versus anything else out there, that's a big range of difference there. This is just top used functions, right? So a large variety of things can be done in MADlib which cannot be done in other things, and I don't remember all on top of my head. The third, I would say, is the performance. The difference in performance between running anything in Hadoop, any other Hadoop ecosystem tools or versus HAWQ is another one. And then the last point I would make is HAWQ with PXF and MADlib, now you can access your entire Hadoop ecosystem data in one SQL, right? Outside that, now you're doing MLlib for something else, you're doing PySpark code for something else. It's hard, and you have to design a workflow just to run one analytics. You have to move data around, you have to retranslate that data into one logical code which you have, which can access all that data set. Now, if you think about how long it would take you to write that code and write that data flow or workflow for that process versus writing a simple SQL which does that for you where the data exists. That's where the real difference is. So a productivity of a data scientist is much higher when you're doing something simple. You're not spending time, wasting time, I would say, moving data around or cleansing data or reformatting data. And that's the key value, I would say. Anything there? Question? No? Cool. So now let's say there are a bunch of functions, as we saw, right, which MADlib can do. But let's say you don't have something which you built in-house. Like you build something which is proprietary to you, and you want to implement that logic in HAWQ. You want to run it as if it's SQL, right? What do you do? Now, let's say you have a data scientist who knows only Python, or only R, or only C, or only Java, and he has built something really cool, a really good data science model which you want to implement inside the same SQL statement. And you want to make that logic available to entire business unit, business group who wants to start, plotting that data based on what the data scientist has come up with. It's as simple as basically taking that code and putting it in a programming language, PL function, right? PL function is which you might be used to seeing in any other databases, right? Oracle has its own function capabilities. Postgres has its own way. Every database has its own way of doing things where you just create function or a stored procedure. This is basically a user-defined function which you can create in HAWQ. You just say create function, logic of your code, be it Python, be it R, whatever language you write it, and then end it with, by the way, this function is R. And now it knows that it needs to talk to our interpreter to execute that function. And that function, because if you remember the architecture of HAWQ, because HAWQ segments are running on all the data nodes where your data exists, it knows how to parallelize that data, parallelize that logic, and run on all the machines. As an end user, as a business, as a data scientist, you don't have to worry about threading or parallelizing at all, right? The infrastructure takes care of that for you. And the best thing is, once you build that, once that logic is built, you can just say select star from my Python function in your SQL code, and it runs as if it's built into the product.
But you have to configure all your worker nodes to understand Python or R, right?
Correct. So the question was, do you have to have the languages or the interpreters on all nodes? So all data nodes need to, the answer is yes. All the data nodes need to have, let's say you're running a Python code. If you want to parallelize that code to run on all machines need to have our interpreter, right? Same thing with Python. By default, you will have C is different, right? C is a little different because in case of C, C++ code, it gets built as a shared object. You just deploy the shared objects on all the nodes. It's already pre-compiled, so you don't have to worry about compilation at that point. But if you have Perl, Python, those are the two things which are pretty much any Linux install comes with those things, right? So you don't have to worry about that as much. But the other, one thing which is usually missing is R. Linux, by default, you don't have R installed on every Linux environment. So that's something which you would install if you want to execute on a particular data node or all data nodes. Cool. Anything else? Cool. So a few benefits, right? So now this enables your data scientists to continue using their language of choice, right? You don't have to learn a new framework. You don't have to learn a new language. And it enables writing that code without worrying about how to parallelize that. It just works efficiently on your Hadoop infrastructure. And it eliminates, the biggest thing I think is it eliminates data motion. You don't need to move data around. That was the whole idea why we all came into Hadoop world, right? You just bring your logic to the data where the data resides and execute it there. right? Don't move data around or don't reshuffle the data formats just because you have to run analytics on top of it now. So that is the use case where I would use this for. So a quick recap on HAWQ and advantages of HAWQ. Right? It brings advanced analytical at a performance which you expect. Right? You get exceptional MPP performance. Right? It is built into the framework. Low latency queries, petabyte scalability, asset reliability, fault tolerance, everything is built into it. It's the most complete language compliance, right, from SQL, ANSI SQL standard. Leverages existing SQL skills in your business, right? It brings OLAP functionality into your data lake, which was missing, right? All those things come out of the box. With MADlib, now integrating it with the MADlib, it lets you use the same infrastructure which you have built, which is underutilized today. It lets you use that for data science at scale, right? Running data science models at scale directly on that same Hadoop data. Elastic architecture, you can add nodes when you need. You can drop nodes as you when you want to reduce your number of nodes. It's easy to scale up and down, expand or shrink the clusters on the fly. This is also designed in a way that you can run it on a bare metal system in your data center or in the cloud or anywhere you may have, right? It understands the infrastructural issues and the optimizer can plan accordingly. And then that advanced query optimizer is a key thing there, where depending on where your data is and depending on the histograms built on top of your data set, it knows how to create a plan which gets executed in the fastest way possible. Now, a few reasons why HDB is highly performant, right? There are a few here listed on the screen. I will touch on the key things here, which I think are critical. We talked about the optimizer, right? I'll spend a few more minutes on the optimizer piece here. We are really proud of that optimizer. It's a common optimizer which is being used between Greenplum and HAWQ. It's a cost-based optimizer we started building about 4 or 5 years ago, and it was built ground up. The reason it was built that way was because all the optimizers out there are serial optimizers. So the data processing happens in parallel, but all the other optimizers there, even if you have a cost-based optimizers, those are processing one unit at a logical time. Most of the master nodes where the data planning happens, query planning happens, have multiple nodes or multiple cores. Those don't get utilized as nicely as this optimizer does. That's the first one. So now you can go through multiple execution plans in the same amount of time. And you can pick the best plan available with this optimizer. The second point I would say here is with that particular the optimizer is it brings it's a very pluggable model, right? So we have built it in a way like imagine Linux kernel, right? You have a Linux kernel which is running and you want to update a driver. You don't have to restart a system. Right? You can plug in newer ideas, newer models into it. Same thing happens here. So let's say UC Berkeley, some student builds a really nice, cool algorithm to come up with the cost estimations better than anybody else. It's easy enough for us to plug that cost estimation into the existing optimizer which we have built. That's how the optimizer has been built. So it's easy enough to plug in all the newer features which are coming out of the universities, right? That's one interesting thing. We talked about the scalable, linearly scalable query dispatcher, how it knows which nodes to run queries on based on where the resources are available and where the data is, right? C++, so one thing which I would like to make here, a point I would like to make here is HAWQ came from Greenplum, which came from Postgres world. So it's all built in C++, right? So there is no JVM, right? No JVM anywhere. You don't need that anywhere. The entire execution happens in C++, and all even the HDFS scans, right, are all native. So we have extended libHDFS to read and write natively from C++. You don't have to worry about having any JVM layer there. That's a key place, and that's where we get a lot of performance benefit from. Right? We talked about data matching compute to data. Let's see, anything which we missed. I think I mentioned that. Let me get back to that one again. The dynamic pipelining piece, right? So if you're doing Hive jobs on like a MapReduce or anything else like that, and you have a large data set you want to compute, if you look at the plan, it's usually taking that data, sorting it, shuffling it at every join or every group by, just because that's the only way it knows how to do the job. In this case, we don't do that, right? If you're joining or you're sorting or you're grouping by, you're building aggregates, we do that on a hashing algorithm. So we hash things and we keep in memory, we move that data in memory. You don't have to sort and move it based on how it gets sorted or how it gets bucketed. We bucket that using hashing algorithm, which comes from our Greenplum heritage. So we got all the maturity which was needed for an MPP architecture. We brought it from there into Hadoop world. So there is no shuffling and sorting happening in your query processing anymore. Looks like you have a question.
Yeah, no, I'm confused. Are you saying that will HAWQ work on data I have already, or does it have to get kind of like pre-processed, or like Hive, the way Hive kind of moves data for you, right? When you load a Hive table,
Yes.
it moves it for you. I mean, does HAWQ do the same sort of thing, saying like, oh, we have to hash all these, do we have to distribute it by key or something like that?
Yeah, so question was, do I have to, the way Hive moves your data, do I have to move data in HAWQ to benefit from this? Right. The answer is you can continue using external data where it is, or you can move it into the HAWQ environment the way Hive would do it, right? Same idea. If you move it into HAWQ environment, that will be faster to process the query, for sure.
It does some sort of clustering or something like
Yeah.
that? Clustering or distribution.
Distribution. So what happens is, like, for example, let's pick. Let's see how. So moving data in is just moving data into a space which is owned by HAWQ, right? So HAWQ owns that space, and you're not necessarily cleaning up that data or adding data or anything like that. If you want to add data, let's say you have some file which you created. Let's say you created a Parquet file somewhere. You have a 50 terabyte, or that might be a little big. Nobody creates that big a Parquet file, right? Let's say you have a 50 gig Parquet file which you created, and you know that structure of that Parquet file fits into your HAWQ structure of that table. The structure matches. You can just say HAWQ register that file in, and you don't have to move the data. Data could reside where it is. You don't have to move that data. But if you want to move that data, we will take a look at moving data piece. I've included those things so that it's easier for you to get started with HAWQ and MADlib.
I thought the whole MPP concept was to kind of prearrange data in a way that you're most likely to query it.
Yes. So that's the next slide. So let's see. Where is that? What's that? Yeah, I knew what the questions will be.
Tell me more how it
So the question, I think I have something here, a pointer, where I was going to talk about that anyways. Yeah, so the point where we say the per table directory storage, right? So the point over there is, I think you have used Greenplum, I'm assuming, or you know enough about MPP systems.
Well, no, I mean, I see MPP and I'm like, wait,
Yeah.
I've never used that.
Yeah.
Infrastructure that was at all MPP.
Right, so MPP systems, right, the way traditional MPP systems work is, including Greenplum, Teradata, Netezza, Vertica, you name it, right, anything which distributes data on multiple machines, any clustering algorithm, the way it works, when you insert data into that, it figures out, okay, typically you say, here is my transaction data. Let's assume it's a retail data set, right? You go to Safeway, you buy something, that becomes a transaction line. You take that data set which holds your transactions, and you say, distribute this data nicely on my cluster. And for that, you would pick something like transaction key or transaction ID as your distribution hashing key. That way, data is nicely distributed. In case of Hadoop, Hadoop already knows how to do that. It does that at block level, right? So when you say, here's my half a gig of data, it splits it into 2 or 3 blocks, depending on your block size, right? And puts it into those different nodes. You don't have to pick a distribution key there. If you go to the Greenplum world or any Teradata world, you still pick that key, right? In this world, you can just say use Hadoop storage system, and it just uses that. And the reason I put this slide is because if anybody has used HAWQ 1.0 or has used Greenplum, you would have a distribution key for every table, because that was the heritage. That's where we got all the good stuff, plus something which didn't work nicely with HAWQ, Hadoop world, right? In HAWQ 2.0, that has been fixed. So now when you look at the way files are stored, it looks just the way, like if you go to Hive data warehouse, You have a database, you have a table, and every table is basically a directory, right? Same way HAWQ will do it. On the file system level, you see a table name, a directory for each table, for example. So the distribution happens at block level from storage perspective. Now when it comes to the processing power, that's where the power comes from, right? So now you have two tables where you are joining, let's say, customer information and transaction. And you're saying, find me or get me data together for all the information about customers who have bought stuff in January 2016, right? At that point, the way the data gets joined, if you translate that into Hive or MapReduce, you would do the same logic, but it will run into MapReduce problem, right? Where you're taking these keys, sorting the data on your, let's say, in this case, you need to sort it on customer information, right? Customer ID. You sort that and you shuffle it around. You don't shuffle it, but MapReduce shuffles it around for you so that all the data is clustered on different nodes and you bring it together. In HAWQ world, you don't need to do that. What happens is, based on the data you're accessing, first of all, what will happen is it will find where is your January 2016 data. It will eliminate all the partitions, other months, which you don't have to read. It will go read the data which you need to read from, and it will go to those blocks. That's the first step. The second step it would do is it will look at your customer information, and it will see where is this list of customers who actually bought stuff in these months. It will pick that data, bring it into memory. It will hash it based on customer ID, and the hash based on the hash values. It doesn't have to sort and shuffle, right? It will hash it, and it will say, okay, my customers from 1 to, in case of MapReduce, you would do 1 to 100, go to first node. 101 to 200 goes to second node to do the join. In case of HAWQ, you don't do that. In case of HAWQ, what happens is the optimizer takes a look and says, which of this is larger volume? Transactions is a larger volume. I don't want to move large data set. I want to move tiny data set where the large data set is to join that data, right? So the way it looks at it is like it finds all, it basically does a hash calculation on, it basically does a hash on the customer key here, customer ID, a customer column, and it does a customer ID hashing here and says, all these hashes, I need all the keys from all these nodes. And the smaller data set gets moved to the larger data set, and it gets joined there, and the result sets go back. And that's the difference. You don't write to HDFS every time, right? You're not shuffling, you're not sorting, you're not writing to HDFS all the time in your intermediate steps. This is a simple use case where I'm joining two tables. Imagine where real world use cases come. You're joining 20 tables. You're doing 15 group bys. You imagine how many HDFS writes you're eliminating. And that's the key where HAWQ gets all the performance benefits. That's where it gets the performance high in this space. Looks like you have a question. Okay, you good with that? Nope. You good? I think we talked through most of this, but I will touch on some of these things here. Let's see, where do we start? So management, right? The reason I put this slide is if you're used to HAWQ 1.0 world, the management of that cluster was slightly different because of the heritage from which came from Greenplum world, right? Now it's simple. It's Ambari deployed. You just go to Ambari and say, add these nodes, add HAWQ into these nodes, and it just does that. You can do the same thing from command line CLI as well. And if you are interested in how to install stuff versus how to use HAWQ, I'm pretty sure within a month we have a meetup here at AutumnWorks where we'll be talking about how to install it. There was a webinar which happened yesterday. I'm sure it was live streamed. It might even be recorded. So if you guys want to do that, we can do that as well. That's the command line interfacing. Yarn integrated 3-tier storage management. That's one of the key features which comes into HAWQ, right? So every time you run a query, it talks to Yarn as every application in Hadoop world should. It talks and finds out where are the resources available, and it goes and starts executing. That's the first level. That's a simple thing. It happens with every Hadoop-based service which is integrated into Yarn. The second piece which happens is at resource level, right? Depending on which user group you come from. If you're a CEO, you get a higher priority jobs, right? Or if you're a VP, you get a higher priority jobs versus, let's say you're a data exploration or deep data analyst or data scientist, where the company knows you're going to run massive jobs at some point. You don't want to take over the entire cluster. Then you can tweak the settings saying you can run only up to a certain, you can use only up to a certain memory space on the nodes. This is beyond what Yarn does, right? You have yarn options out there, and within that space, you can define this group of users can use X amount of memory. It can use X amount of CPU. Even in that, you have options of saying this particular user group gets higher priority on CPU execution time versus the other users. So there is a lot of good things which come from the database world, right? The databases, data warehouses have been doing this for last, whatever, 15, 20, 25 years, right? So all the goodness comes from there. I will actually show an example of hcatalog read access, so we'll talk about that later. Block level storage, so we talked about that a little bit, where you asked the question of how do we distribute data. So it's distributed based on the block level. Let's jump to the next phase here, demo. Any questions so far? Yes. So the question was, does once the query results are back, do we cache that result somewhere?
Or do you just cache the information of the blocks that it came from? Is there some kind of cache mechanism that's...
So your question is it on the I/O reads from HDFS or on the user results going back to the BI tools or anything else? Like where is the I/O tool? No. So the question was, do we do any caching at HDFS level or some other fashion to do quicker reads? The answer is no. We don't cache anything beyond what an operating system or any Hadoop ecosystem will do. We don't do any special caching there. No.
But you said like it's in the memory, in-memory computation.
So once it's read, for that query, your data is already in memory and it's processing that data. I think the question was, if I have a repetitive query, do you still have to read the data, right? So we rely on operating system to do that caching for us. So if you think about it, operating system, right, when you do an I/O scan from there, from that particular disk block, that data came from there into file system's cache, right? File system already has that in memory. The second query comes in and says, get me that data. HAWQ doesn't cache it. HAWQ checks with the OS and says, do you still have that, right? Get me that data. The OS will have that in memory space, and it will just give the memory pointer to HAWQ, and HAWQ will just execute on that. HAWQ doesn't manage any cache. Yes.
So if you keep repeating queries, the same queries, it's just going to take the same amount of time.
Correct.
There's no significant improvement.
Correct. But you still have to process that data, right? So typically, the HAWQ users, they're not doing simple things like select star. They're doing complex workloads on it. And that workload, you still have to process that. And if you want to cache that result, that's the end result going into your application there. And I will talk about that a little bit in that demo, in the next demo.
So in that case, how does the streaming work? If you have streaming buffer data coming in, do you have to query the same? If you just want to query the newer data, right, and store the results of the previously processed data somewhere, does it happen, or you just have to rerun the full query?
So I didn't get the exact question. So question is,
The streaming data that's constantly coming into HDFS.
data is coming in from HDFS or to HDFS? And you want to store that data, right? We'll talk about that right after this.
I think what you're saying is where do you persist the data? If it's coming into HDFS, it has to be persisted on HDFS. Then you can query it. Or maybe you're asking the question whether what happens to the data being streamed between the HAWQ worker nodes.
Yeah, I think the second one, yeah.
The second one, right? Yeah. So in those cases, you would typically rerun the query and reprocess the data. The intermediate data is not reutilized.
There's no way to do that.
No. There's some buffer caching, like you said.
Yeah, there is a light buffer caching there, but it's not something which we rely heavily on. No. Cool. Let's talk about a demo set here. Half of the top half of the demo is something which I have already executed, and then bottom half is something which is related to HAWQ and data science and MADlib. We will go through that portion right now. So, but I will explain this so it makes much more sense, right? So this is basically credit card data sets which are coming in from your credit card transactions. all the data which was streaming in from credit cards, it's going into the Gemfire product which we have. It's an in-memory data grid, right? You want to start getting more transactions in. You just add a few more nodes, scale that Gemfire cluster just the way you would scale out your Hadoop cluster for more storage, more processing. So data is coming into that. The green power buttons there are basically Spring Boot apps. So Spring Cloud Data Flow is another portion which I did not mention, I think, earlier in our data portfolio. So it's basically it's a collection of different Spring. So Spring, do you guys know Spring? Spring is a Java framework, right? That's where Spring, the term Spring came from. Most of that is it's coming from Spring Data, Spring integration packages. These are all open source packages. Spring Cloud, which came from the Netflix runs everything on Spring Cloud. All the streaming happens in Spring Cloud, right? That's where it came from. And Spring Boot is a key portion here. Spring Boot is basically it's a nice way of writing your Spring jobs and creating microservices for smaller job sets, and you can tie those things together. That's at a high level brief of what Spring Cloud Data Flow, how it's designed. And what it does is basically it has taps into multiple sources. So you can say, get my data from Gemfire, which is streaming in, collect a bulk of that, and persist 1,000 rows into HDFS at a time, because you don't want to write one row at HDFS at a time as it is streaming in, right? So to avoid that, you can collect some data set, put it into HDFS data lake, and once the data is in your lake, that's where we will do the rest of the demo, and we will start there. And then just wanted to showcase one more thing where to have a feedback loop into your system. The idea was fraud detection on your credit cards. That's the demo which we had built. It's a much larger demo. With short of time, we probably would not go through all of it. So the idea is, once you have built a model to predict your fraud, it can be cached in multiple things. You could use Spark to cache it. You could put it in Gemfire and do complex event processing right into Gemfire, or you could put it export it as a PMML and execute and score that the new data which is coming in Spring Cloud Data Flow itself. It's right here. So we'll show a path from once your data lands in HDFS, how do you build models and how do you export that back into PMML? We'll cover that portion. Any questions? Does this make sense, this workflow? Yeah.
Does HAWQ support online learning? That is, modifying the models as new data appears?
Yeah, so there isn't any, so you need to execute that model again. So sorry, the question was, does
MADlib, not necessarily HAWQ.
Right, MADlib and HAWQ, the combination, is there a way to online update the predictive model as new data is coming in? The quick short answer is it's not built into the product to auto run that model, right? Somehow when you have data set, the newer data is coming in, you need to run that model to build on top of it. And there are various tools which people use, and you could continue using those.
I just want to make a comment on the online learning. So the algorithms in MADlib you would rerun the model to retrain data. So the models are not implemented such that as data streams in, the training happens in real time with the new data, right? So what you would need to do is to actually rerun the model on the collection of data which you have. Real online learning is like an open area of research, and there are some basic online learning algorithms which are implemented in the enterprise, but as I say, it's not that common right now. But lots of promise, definitely lots of promise.
You have to choose how often you train.
Correct. Yeah. Yep.
Every data point is one new tweet.
Correct.
Yep.
I might tap into you again, Frank. Thanks for being here.
Oh, my
for the
pleasure.
remainder of the thing. Okay, let's go and take a look at Apache MADlib. So Spring Cloud Data Flow, I will just walk through the process, right? So just wanted to showcase a few things here. So there are built-in tools and connectors into Spring Cloud Data Flow, right? So you can just say, get me data, get me a file, get me data from Gemfire, get me data from Redis, get me data from my Twitter host, right? Whatever it is. And there are things built into here. Oops. So MongoDB, Rabbit, whatever it is, right? You just say get me data from here, or sync that data into any of those things which are built in. Just drag it, say HTTP, you define, and it builds you a nice little query here, which is a single command line execution. If you look at it, it's basically saying go. This is where my data source is. Oops. Is it readable? No. Let's do that. So take that data which is coming in from here. Convert that JSON data set which is coming in from a credit card transaction into Gemfire. Take that data which is JSON, convert that into CSV, and use a bunch of code here which has been pre-built for you. Oops, sorry about that. Display is not working well. There we go. And then translate the JSON logic and convert that into a CSV. So street address, comma, latitude, all that stuff, and put it into my HDFS directory here. HDFS directory, that particular directory, and this is my URI. So once you do that, the Spring Boot app will run all the time, and it will keep collecting the new data set which is coming in. And you say limited at a certain number of rows, it will keep writing a new file every certain rows. You don't want to write smaller data set in HDFS, right? Because otherwise you will end up with too many blocks problem on your name node. So
a machine data scientist should be smart enough to do this, but is too dumb to learn something.
no, this is not data scientist, right? So this is the person who's building the application. So you're the person who's building your credit card processing system, right? Or yeah, data engineer like myself. So this is what I do on my day-to-day basis. So moving data into a place where data scientists can then start analyzing the data, right? So once it's there, that's where the data scientists come into picture. So let's go here. Just want to make sure it's there. Okay, so that's your HDFS data which has been collected over time, all that stuff, right? We just copied that data into this space, into this small environment. So this is a single node, same HortonWorks sandbox running with HAWQ and other tools on Amazon right now. It's a small machine. So we just copied that data into this space. Let's make sure we got something here. Okay, so that's your typical CSV data, right? We took that JSON data and converted it into CSV file, so it's readable by Hive, for example. So let's go to Hive. I believe I've created an XML table here. Let's see. I'm going to connect one more time here. Is that readable?
Yes.
Yep, perfect. So let's go back. So I'm going to show two different ways of accessing the same data set, right? So this is Hive. This is Hive external table. Let's take a look at HAWQ external table. So if you look at it, let's go back to Hive first. So it's not that much different from usage perspective, right? It looks a little different from the output of describe versus describe on SQL. So let's look at what Hive is doing, right? It has a definition of all the columns which exist in your CSV, data types, all those things, and it's looking at the name node and your Hadoop file where it's going to read data from, right? Very similarly, you can build an external table in Greenplum, HAWQ, and you just say that's my name node and read all my /txt. Oops, that under scdf data directory, read all the stuff which is star.txt, the files which we just saw, right? And by the way, use profile. So profile is a way of defining what is that external table in HAWQ, right? You can say profile HDFS text simple because it's just it's a regular CSV text file, right? And you say delimited by comma because it's a CSV file, right? And then you can just do the usual things, count star from the table, or you can do something, anything else which you might be used to doing in SQL, right? Select star from, limit a few rows here. Let's do similar thing here, right? It gives you the same data set, all that stuff. I just wanted to show the command line piece here a little bit before we jump into Zeppelin, right? A lot of data scientists are like using some notebooks. Zeppelin is one of the favorite ones. The best thing, it comes pre-built with your HortonWorks distribution. If you have a HortonWorks cluster or if you have a HortonWorks sandbox, it has pre-built Zeppelin into it. So I'm just going to use that for a little bit of demo. Plus, it has a nice way of visualizing a few result sets. So makes it life easier instead of building data, getting result sets and running it in something else like Tableau or something. Right? Let's jump to Zeppelin. So Zeppelin, cool. Is this readable? No. So are you familiar with Zeppelin? Are you guys using Zeppelin? Yeah. Let me talk a little bit about Zeppelin before we look at the sequels here, right? Come on. So Zeppelin, the first time you get Zeppelin, it is basically an interpreter with a lot of cool things which you can do. You have to define what sort of things are you going to do in this particular notebook which you created. So you want to access HDFS, you define where your HDFS is, right? You want to access HAWQ SQL, you want to define where is your HAWQ SQL, right? You can use JDBC here, all that good stuff. If you're using Python, you want to define, okay, when I say /% in my notebook, this is what it means. Go execute using Python interpreter, read that information based on that. You can write shell scripts, you can write Spark code, right? And how to execute that, all that stuff. You need to define it once, and then you just go back and run your things there.
I'm saying, is Zeppelin run in a browser or is it?
It is a browser.
Oh, okay.
Yeah.
So it's a lot like, what is it, Jupyter?
Yeah, it's very much like Jupyter, yeah. Come on, it's just the difference is this comes built into Hortonworks sandbox, so I just use that. So yeah, so the same command which we ran there, it's %file, right? %file is linked to my HDFS command, so HDFS DFS commands. So that's the same list of files which we saw, right? And now jump into HAWQ. We saw this external table definition for to read HDFS files, CSV files. It's the same data set you're looking at, or table definition you're looking here. And this is the same query which we ran in SQL. It shows a little nicely. Zeppelin knows how to, project data set nicely. It's readable more than command line, right? You could do the same thing, the same data. We'll take a look at the same data multiple different ways. So you could do this exact same thing which you did using an external table on HDFS file. You could do the same thing with Hive, right? So let's say you have a data in Hive, right? Remember we created that external table in Hive. You could, if you have a table in Hive or an external table in Hive, you can go to HAWQ and say select star from H catalog. Oh, sorry, when I zoom in, it doesn't like it. So all you have to define in your HAWQ SQL is hcatalog dot your namespace and the table. The table which we created in Hive was transactionals_ext. Once you do that, you can do ANSI SQL against your Hive data. So the reason I'm showing this is if you have an existing Hive data warehouse and you want to start doing machine learning, you want to start using MADlib on top of that Hive data warehouse, this is an easy way in, right? You don't have to migrate data day one, because that's always harder. You may have petabytes of data in Hive, and you want to start leveraging HAWQ for interactive SQL. You don't want to move that data day one. You can do it over time. It's a good idea to do it over time, but you don't want to start doing that whole thing day one. This is an easy way to get started with HAWQ. You're not moving data, you're not retranslating anything, you're just saying, go get that information from hcatalog and run my query, and it knows how to do that job out of the box. So that's one. And let's say you find value in bringing that data inside HAWQ instead of leaving it somewhere else, right? It's as simple as basically saying insert into, so it's as simple as saying insert into my internal table. Now in this case, my transactions are internal table, grab it from PXF based file, which I just created, right? The CSV file reading via HAWQ external table. You could do the same thing using the Hive table which you had. So you can say insert into transactions. Come on. Insert into transactions. I'm creating a different table here. Insert into transactions Hive, which is basically data which I'm getting from a Hive external table. The only reason I have to do this translation is because if you remember, let's go back that way, it's visually there, right? HAWQ lets you define external table data types out of the box, right? So HAWQ external tables already had the definition of, hey, this city is text, this amount is precision, double precision, all that stuff. So when I inserted data from or versus Hive, the way I've set it up here is everything is a string in my external table, Hive external table. So when I had to move it here from an external Hive into internal HAWQ, I had to make sure that, hey, that you need to translate as text, this needs to be a float, right? Data type translation. And it inserts data from your external Hive data set into HAWQ.
Because everything is string in, or strings in Hive?
I'm not a Hive expert, sorry.
No, but I mean, I think you showed the Hive schema somewhere on the
Yeah.
page. And,
Oops.
it showed,
Yeah.
yes, everything's strings, so you have to tell it, no, that's double precision.
Right. I don't know. Is there anybody Hive super user external tables on Hive? Yeah. Okay. So the only way I do Hive external tables is strings. It's just it works all the time. Otherwise, I've had problems.
Works a lot of other data types, but just maybe for demo.
For external tables? Yeah, this was external only. I'm not sure. I don't remember. It was just easy enough to build it. It's a small data set, right? So that's why it looks slightly different. The only point I'm making is this looks like a single line versus the data coming in from Hive. It looks like you're doing something, and that's what I'm doing there. Cool. And then once you have your data, right, you can do a lot of good things with it. This is a simple example. I have a customers table. The customers are related to the transactions which were coming in, and this is a nice way to do, hey, customer age distribution, right? A simple SQL which shows you different, how many people are 25 versus 26, right? It's age distribution. You can visualize it in different ways, and this visualization is all Zeppelin, right? It's nothing to do with HAWQ. It runs ANSI SQL, so if you have any tool which you have, just plug into HAWQ, and you can continue using MicroStrategy if you want, or whatever else you want. You can continue using the same BI tools with HAWQ out of the box. Same thing about account balance by state. So it's doing a basic stat on, hey, in what states is what is my account? I think it's sum of account balances in that state in this particular 10,000 transactions which I just collected. Right? It's a simple. Good. Yeah. Come on. And then now let's jump into the MADlib portion. Right? The first simplest example of MADlib is a summary function. You just give it a list of a table, and it goes and collects summary statistics of that table. So once it builds your summary, you can basically, now here you can say group by certain things. I just said just group by null, right? So it basically collects stats on all different columns in my customer table, right? And it builds a summary table. So once you have summary built on a particular table, you can just go and say, find me information about these target columns. So it has like 50 columns, right? Go find me information about age, credit amount, and duration. And then you can do something nice as find an entile function here, right? So how many of my users are, what is this? Credit duration. How many credit durations are in the first tile versus third versus median, right? How many users are in the median group? So it's like we don't have to worry about building code. Imagine doing this same thing in like Python or R or something else, right? You're writing code. You're writing minimal code because MADlib has implemented many of those things, and it has parallelized. This is a simple function. Once you start doing complex thing, it becomes much more meaningful at that point, right? Let's take a look at I have a function for it's a PySpark code, right? This is a plotter function. It takes the parameters on where do you want to plot a certain thing, and it plots it. That's a plot function, the first stop. It's just a helper function to run this next portion. And this next portion is what it is doing is taking that transaction information which we collected, and it's reading all the transactions and finding, and it's plotting information about if a person's address is at a certain location, and if that person is 1,000 miles away, more than 1,000 miles away, and that person is spending beyond what his usual spend is, plot that person.
You mean 1,000 miles from home?
From home, yes. So if I live in San Francisco, 9411121, if I am in New York, or my credit card transaction is happening in New York, and it's happening over $1,000 or whatever my limit is, right? So that's what this is. And then it takes this function and it sends it to that plot function, the helper function which we built, and that function just plots it here, right? And it's basically a pictorial way of saying how many transactions are happening over 1,000 miles away and which are getting.
What's MADlib's role in that?
No, this one is not. So the reason I put it here is it's PySpark, right? So to do the similar thing, I should have put a MADlib function which does the exact same thing here. I didn't get a time to do that. So idea here was you're writing a lot more code. So what that means is, as a data scientist, if you're building all that in logic, you're going to spend more time in writing 1,000 lines of code versus writing 20 lines of 50 lines of SQL. SQL is a nicely compact language, right? And MADlib's role is MADlib brings that compact SQL strength. It brings the logic to that compact SQL and makes it much more powerful. That's
Where'd
much.
the data come from in this platform?
This one is the transactions data set. Yeah, it's the same, not suspect transaction. Yeah, it's a suspect transaction built based on that criteria. What was it? Yeah. So this code is not even doing logic behind it, right? It's not predicting it. It's just plotting it. It's just code to plot it, right? Let's take a look at a little bit more. What is this? So a few things. Remember that big eye chart where we saw a bunch of functions? We will just showcase a few of those. So a typical way of, like, if you want to run, is this readable from back, or should I zoom in? It's good. Okay. The problem with zooming is the moment I zoom it and I have to move around, it just blows up. So a simple thing, like if you want to run a logistical or implement a logistic regression, right? MADlib has built-in logistic regression. Now all you have to do is give it a file name, a table name of where your source data is and where it should store the output of that data, and give it an array of what you want to build regression on, right? And it just goes in and does that. You don't have to implement logic to do that, right? It's all implemented within MADlib for you. Same thing, and then once you have, so typically the way you would do it is you would take the transactions which you have. Sorry about that. You would take the transactions. I'm going to zoom out. You will take the transactions table and pass it as an input table to the logistic regression function, and then the training function, and then the output would be in suspect logger, right? And this 0 is just because the function finished without error. If there was an error, you would see an error code there. And then once you have the output ready here, then you can just do select star from the table, collect that data, which is your regression output, right? And then that's your regression coefficient, which was built based on your data set which you just provided, the transaction files which we had on HDFS. Once you have that, you can do a lot of things here if you're a data scientist. But if you want to, so if you build something and you build a predictive model and you can't score it against something, it's not meaningful, right? So once you have a cool model built, you want to operationalize that. You want to take that data, not just reporting and putting it on a nice presentation PPT and sending it to CEO saying, oh, we had 1 million frauds. It's not useful, right? As a credit card transaction company, you want to catch people in act and stop them before it happens. So a nice way to do it is put that logic back in your application, which is actually processing your credit cards. The simple way to do it is, in MADlib, it's like you just take that same model which you just trained, and you say, by the way, export that in PMML, take that model and export it as PMML, and this is your output of PMML. You take this PMML, and if you remember, I'll go back to that diagram. So once you export that PMML, you can put it anywhere. In this case, it could go into PMML evaluation in Spring Boot app, where your application is actually processing data. So as soon as a credit card transaction comes in from New York for Tushar, it will say, wait a second, why is that getting transacted here? He just spent $100 at a restaurant in San Francisco. He cannot be spending $1,000 at a bar somewhere in New York, right? You can stop that act based on the models which you have built. Now, this is a simple model. You could be doing a lot more with the MADlib functions. You saw the list of functions. And if you have your own functions, right, it's as simple as basically instead of training this, you can add your own logic in your favorite language of choice, right? Python, R, C, C++, Java, and extend the capability which you already have, and let the SQL guys continue doing what they do best, instead of spending time moving data around and all that stuff. So that's the benefit of having HAWQ and MADlib and that combination. And there are a few other examples. If yeah, please go ahead.
What would be the easiest way for me to play around in the sandbox?
Good question. Download the sandbox. Step one. So you can download it from both Pivotal as well as Hortonworks platform. Download website, and then it comes pre-built with HAWQ. You just look for the one which says HAWQ Sandbox on Hortonworks platform. I think there is a Hortonworks 2.5 which went out recently. I think the existing HAWQ is built on Sandbox on 2.4. I think, could be wrong. And then in next few weeks or maybe a month or so, you should see the latest software which syncs up between 2.5 and HAWQ 2.01 instead of HAWQ 2, all that stuff. It happens in a few weeks' time. And if you have questions around, I wanted to, oh, what happened here? There we go. And just wanted to close this out here. So your question was, what do I do? How do I play with it? So today you can just go out, download the HDB sandbox from Hortonworks website or Pivotal website. It's the same website. If you want to do, once you download it, once you start playing with MADlib a little bit and you want to do, hey, what else can I do? How deep I can go, right? You want to start doing some data science stuff. 12th of next month, October 12th, we have a hands-on workshop in our Pivotal office in Palo Alto. Please feel to stop by, register for that and stop by. We will be doing hands-on workshop in Palo Alto office. And if you have your friends in your IT side of your company and they want to learn how to install in your existing Hortonworks cluster, how to install HAWQ, how to install MADlib, right in this place, 20th of next month, we will be having how to install HAWQ and MADlib on Hortonworks. So if you have friends who do that job on a day-to-day basis in your companies, send them over. Cool. And then, yeah, feel free to reach out to me, to Sharp@Naker. Thank you guys for coming. And if you have any questions, any other questions, we can take those offline or online. Thank you.